Good morning, everyone, and welcome to our presentation on automating production-level machine learning on AWS. My name is Tanya Vucetic. I'm a data scientist at Onica, a Rackspace company. You'll hear us use Onica and Rackspace a little bit interchangeably throughout the presentation. Today, I'm joined by Mark McQuaid. He is a practice lead of our data science and engineering department. He'll be going into detail on our subject matter today. And Jerry George, he is a data science architect who will be handling the Q&A throughout the presentation and at the conclusion of the presentation. So please, I encourage you to ask questions in the designated Q&A portal to the right of the presentation. So let's get started. So a little bit about Onica. Onica is an AWS premier consulting partner that offers expertise across the entire AWS stack of services. We have achieved all of the AWS competencies, allowing us to drive customer success wherever they may be in their cloud journey. And since our company was born in the cloud, everything we do adheres to best practices for cloud native development. And today we'll be talking about the work that our data science and engineering team has been doing for our customers in the machine learning domain. A recent survey reports that data science and machine learning teams are spending way too much time on infrastructure deployment and engineering, and not nearly enough, in fact, less than 25% of their time on actually developing and training and iterating on models. 38% of respondents to the survey reported difficulty in deploying these models at a needed scale. Reasons being DevOps and IT teams not having sufficient resources. Something I deal with all the time is data scientists being expected to build the infrastructure to put their models into production, and a lack of infrastructure within the organization to support the needs of running machine learning models at such scale. 30% of respondents to this survey reported challenges in supporting different and training frameworks, and another 30% reported challenges in model management tasks such as versioning and reproducibility. So with that, I'm going to hand it over to Mark to go over our agenda and further dive into our subject matter today. Thanks, Mark.
Yeah, so hi everyone, and thanks again for joining today's session, Automating Production Level Machine Learning on AWS. My name is Mark McQuaid, as Tanya mentioned. This manager at Onica within our data science and engineering practice. So I'll just quickly go over the agenda. So, I mean, there's not a lot of time here. We don't have a ton of time. So I won't dive too deep technically into the aspects of the model factory framework is what we call it. But, you know, feel free to ask questions throughout, you know, send those in during the presentation, and feel free, you know, you can reach out to me after the fact on LinkedIn or whatever that is, and ask any other questions. So first we'll talk about why customers need ML operations in general. Then we'll go into an introduction to the model factory framework and what that is. We'll talk about some features to model factory, how it works. Then we'll go into some customer benefits, value prop. Specifically, I'll talk about a success story, business use case that we did for a client. And then, as I mentioned, we'll go into a Q&A. So we've entered an age where no business plan is complete without an ML strategy, right? Companies are realizing the value of using machine learning to drive better outcomes for their business. So in addition to using their data in a reactive mode with, you know, business analytics tools, BI tools, companies are harnessing the predictive power of learning. As a result, ML models are becoming as an important tool in business operations as data processing and data analytics tools were, and decade. Your machine learning models to production manner is key. So, however, developing domain-specific ML models is only a first step in your strategy. Operationalizing your models and to production to drive business in more complex than many. So what we see today in a lot of organizations is that there is a lot of research and development that goes into model development. All right. However, the models never get to a production environment. And this is due to the disconnect between maybe the operations or data the ML. So another common problem that we see is that models tend to increase, right? They tend to multiply based on environments as well. Let's bank on as an example, and the number of different areas that can benefit from predictive data analysis. That could be identifying fraudulent transactions, risk of more. So just domains and run, first in a dev environment, models running simultaneously using different hyperparameters as well. So it becomes key lineage without an operational solution in place. A lot of our tweaks to their business needs that will take them deployed into at all, really. So our clients were looking at solution prep.
Sorry about that. I think, Mark, there's a problem with the video and the presentation. Mark would be just with you shortly. Hi, Karen. I think it'd be a good place to probably go on to some of the questions. I don't know, while Mark is joining back in. Okay, so I'll probably run with it till Mark is back. So Corey here had a question. I really don't want to go into the questions right now, but I think as a stopgap, we can go into some of the questions and give you context while Mark is back and onto that specific topic. So Corey here had a question about how model drift and monitoring and reconciliation is handled in production. So for this specifically, Corey, so we use multiple tools depending on what the customer's skill sets are. For example, if we are using SageMaker as our target platform, we often use the recently released model monitoring service, which under the hood uses open source library called Apache DQ, which basically senses the model quality, essentially capturing the data, both the input data set or the features that go into the model, as well as the output, the prediction or the label data set that we get over a period of time, and then detect drift in that. And based on that drift, you can create metrics in what is known as the CloudWatch platform, which is basically the logging and monitoring platform for AWS. And based on those alerts, the appropriate set of teams, the ML teams, would be notified on that model drift. And this varies depending, like I said, depending on the tooling that the customers use. If it's SageMaker, for example, then we use model monitor. If it is Kubeflow, that would be another set of tooling. And all of this would be tied very much into the notification systems that customers use for both application lifecycle management, general web applications and things like that, as well as the ML applications. So they have essentially a coherent system that can serve both their business applications as well as their prediction applications. Okay, so Janina, one of the things that we do as consulting partners is making sure, like I said, we integrate very well into the customer ecosystem, the tooling that they use. And we've often seen that one of the biggest challenges is trying to understand what the customers currently use and what they're familiar with, and making sure we don't bring in drastic changes, but at the same time, we have a well-defined set of process for the machine learning lifecycle management. So in terms of your question, when we onboard customers, one of the key things we do is making sure that integration of the existing models happen seamlessly. And for that, we use a DSL, which I think Mark will go over a bit, essentially bridging the gap between the ML engineers who are in charge of the actual modeling as well as the operational team. So essentially there's a bridge between both the teams, making sure that there's a common language they speak, both in terms of the type of the models, whether it's real-time, batch, streaming, etc., as well as how they want, what type of hardware they want, what type of platform they want, whether it's SageMaker or EMR or ECS, which is a container service from Amazon, or even Kubernetes. Right. Kaushik just clarified that it is for unit tests. So Nasran, like Kaushik mentioned, the under the hood, what we use is DQ for analyzing the data sets. But there is a set of overarching orchestration tools on top of that, essentially things like CloudWatch, Model Monitor container, which sits there and considers the inputs and outputs over a period of time that are dropped into S3 buckets. So there's a variety of tools, but as Kaushik mentioned, under the hood, it is all driven, or the core logic is driven through the DQ library. Yeah, so Fatin was asking, is this cloud agnostic open source tool? Thank you, Kaushik, for pointing out the repository. Really appreciate it. Kyoa, we are having a technical difficulty. Mark, who's a primary presenter for the set of slides that we were going through, he had some glitch in the network and he's trying to join back again. Okay, so I think yeah, Tanya was just mentioning we had a set of common questions that customers ask in this regard. If there is no other questions, I can go over some of them while Mark joins back in, and I'll try to give context. I don't want to go into the questions directly without Mark going over the slides, but since we are in a mess right now, so we'll try to go with it for now. So a couple of questions that are commonly asked is when we go over the actual presentation, Mark would go over as to why Model Factory, in general, as well as how it solves some of the common problems around consistency. And in fact, Tanya just mentioned about that briefly, essentially surrounding the different types of tooling and the frameworks that ML teams use. And that is one of the key problems that we face today. The teams use different types of tooling, and reconciling that across the organization becomes a huge problem. And having a consistent mechanism to both represent that framework, as well as package it, and then finally deploy it across the different platform becomes the actual challenge. And the way we solve that is mostly around making sure that most of the popular frameworks, whether it's TensorFlow, Keras, or Scikit, or any other frameworks, we support that natively and make sure that they can be consistently packaged. By consistency, I mean in terms of the structure, in terms of how you trace back that particular experiment run, and things like that can be handled easily. And ultimately, they are dropped into S3 bucket, and they're addressable by the actual experiment run that you have. These artifacts that I'm talking about could be just plain old pickle files of the Python object for the model training, for the inference, or even the model itself. So all of these are consistently placed in a same location for a specific experiment run. And along with it, there's also the fact that different parameters are used, or hyperparameters are used for the actual model training or even inference, based on whether it's batch or real time. And all of this is consistently saved in a metadata store. It could be either a relational store, such as MySQL, in which case in AWS we use RDS with the backend of your choice. And it could also be NoSQL databases, depending on what the customer is familiar with. And we use essentially we use that tooling to store all of the metadata related to the model. I think I'll go over some of the questions. I'll give priority to the questions that you have. So Corey was asking, what are some of the challenges with working with AWS for model deployment and ML ops that you have all experience, and what are the nuggets that you would share with others that you want to do that want to do this? So some of the key challenges are surrounding what we have seen for the customers are surrounding, like I said, the tooling and the framework of their choice, right? Different ML engineers might use different tools, and even within those tools. So for example, for TensorFlow, Some of them might use the 114, 115, or 2, and they might be drastically different in terms of the data pipelines that they use underneath, or the data API that they use underneath. They might be drastically different. And hence, we use tools like Conda or Docker containers and similar to make sure that reproducibility is there. And Tanya also talked to this, making sure that reproducibility is there, whether it's for training or even the inference environment, is critical. And that is one of the challenges we have tried to solve. The other challenges involve the platforms that we target. So for example, we have had customers that wanted to do training in SageMaker. They didn't mind. In fact, there are a lot of good tooling within the SageMaker offering that offers both training, hyperparameter tuning, and a variety of different things. So they were okay with using SageMaker as a target platform for training. However, they did not want it to use for batch inference because SageMaker has a very specific mechanism to deal with batch inference, and they weren't quite as comfortable using it for batch inference. So what we ended up doing was targeting them to Kubernetes platform, and the libraries that we build out make sure that the platform it is agnostic of the platform, essentially. So you could be doing training in one environment and targeting the inference in another environment. In fact, the same thing for pre-processing. You could be doing the pre-processing in that pipeline. You could be doing the pre-processing or even the post-processing in different environments. So it is essentially a platform agnostic, and you can define all of this in the DSL that I just mentioned earlier, or the domain-specific language that I mentioned earlier. And it is all represented in, very familiar YAML format, which if you come from Kubernetes background, you're not alien to. To come to think of it, Tanya, do you see any other challenges that that you want to address as well? One of the things that we might, perhaps the notebook issue, or essentially the development environments, having consistency across the different environments, because what we've seen is, if you remember, one of the customer wanted to use notebooks as opposed to notebooks, or even IDEs as opposed to just writing Python code, and which is very common, right? You essentially want to develop in Jupyter notebooks or something similar that you're familiar with, that the data scientist is familiar with. And we often make sure that our tooling is accustomed to deal with that. So whether you write it as Python or plain old Python scripts, or you develop using a notebook, we are able to treat it the same, essentially, and then run the training and the inference. And we do this using tools like Papermill and NBConvert and a few other tooling to make sure that all of your code in those notebooks are properly converted into plain old Python files for compilation later during training or inference.
Do you want to talk to our solution around version control and reproducibility?
Yes. Yeah. So we have been looking at several tooling for data lineage as opposed to just model lineage. We talked about model lineage briefly, essentially the ability to trace each metrics down to their model artifacts, or the binaries that we store in an S3 bucket. At the same time, we want to ensure data lineage using tools like DBC, which, in case you're familiar with, that's a common issue that customers say. That's a good point, Tanya. Thank you. Essentially, the customers want to understand what kind of data, or which exact data set they use for training, and finally for inference, if it's a batch inference that we're talking about. So we do allow for that. If it is basic files that you're storing in S3 and passing it as input, what we do is we make sure that those hashes, the E tags as we call it, are properly logged and can be later referenced. If you have lifecycle policies on your S3 bucket, this gets slightly complicated, but Otherwise, it should be fairly easy to trace back the exact set of data that you use for training during that specific experiment. So we do allow for that. And in terms of the model version control, we also log those irrespective. So if it's a whether it's a notebook or a actual code commit to Git repository, we actually log those as well as a part of the training run to make sure you can trace it back later.
It might also be useful to go over specifically which AWS services we leverage.
Sure. So one of the things we want to make sure is, like I said, we want to make sure we are open to changes that the customer wants. So depending on the target platform that they're familiar with, we have done projects on both Kubernetes platform, that is EKS in AWS world, as well as targeting purely SageMaker. So we do training, hyperparameter optimizations, as well as deployments to real-time endpoints for prediction, all in the SageMaker platform. Now, in terms of the other service that we use a whole lot of surrounding or supporting infrastructure services for logging and monitoring, like I said, CloudWatch or EventBridge, depending on what you want to do. We use step functions or the data science SDK, which is becoming more and more popular to drive pipelines, multi-step pipelines, wherein you have, like I said, pre-processing step, training, post-processing, and finally send it out to an inference, whether it's batch or real-time. So step functions is another utility or another service that we use profusely. Is there anything else that I can think of? ECS is one aspect that is coming up depending on the customer's use case, right? So we are also targeting or developing ports or plugins for ECS to be used as one of the target platforms. Sorry.
Another subject that we were planning on covering today was governance and security as it relates to model factory.
Right, that's true. So in terms of security and governance, most of it is driven by the data, and the models that we produce. So all of this are loaded onto S3. So any of the best practices, security best practices, whether it's CIS or any other existing compliance rules that are there for the other projects, like the landing zone project in AWS, still apply to the ML project. So, for example, if you're placing all of this in S3, we would make sure that there's fine-grained policy for each prefix, so that the appropriate roles are the only one who can access it. And besides that, we also have a UI where we integrate with tools like Cognito or identity providers that the customers have. For example, whether it's AD or something similar, wherein you have group level permissions based on what you're able to do, whether you're able to view the experiments, whether you're able to view and probably promote the models themselves, as well as compare different model runs within an experiment. So you're able to control all of that with fine-grained permissions. Tanya, I'll probably pick up a question there. Fatin Haq had a question about how do you package the models and pre-processing steps. So Fatin, MLflow is one of the tools that we use. Besides that, we also use internal, like depending on the customer wanting to deploy to, say, Kubernetes, for example, we would use Kubeflow as well. So it depends on the customer's preference, but in general, MLflow is one of the tooling that we tend to choose, and we have forked over to target different platforms. So MLflow, by essence, it basically runs the experiment runs locally, and it is able to target SageMaker for real-time inference. So you're able to train locally and then push the prediction endpoint to SageMaker out of the box. However, there is limited limited functionality around targeting other platforms. You can do batch inferences in Kubernetes, I believe, using MLflow, but there's not a whole lot of integrations in terms of target platforms. So what we have done is for customers who want a very simple pipeline, we often fork MLflow, and we develop a port, like I said, of their choice, whether it's Kubernetes or EMR or ECS. So it depends on the customer, essentially. And how do you package the models? That's a good question. So once again, it depends on the target platform. If it's MLflow, there are two possibilities. One is essentially package. So once again, so it's packaging model. So I just want to verify if you're talking about packaging the training code, or whether you're talking about packaging the model. So if you're talking about packaging models, MLflow has a signature structure along with, like I said, the choice of whether you want it as a Docker container or something else. So something like using Conda to ensure that reproducibility across the training and the inference.
So I get kicked out. Was that okay?
Hey, Mark.
I wasn't talking that whole time, was I?
You were.
No, you were.
It was good? Like everyone heard everything?
We're still.
No, you got kicked out, and I think as soon as Tanya handed it over, or probably one slide over.
Really?
Yeah.
All right. Do we have time to run that again?
Good question.
Go over the highlights with the PowerPoint.
I could go again. I mean, I don't know if that's, I could probably
up front. So go ahead with your portion of the presentation, Mark.
Man, that was ridiculous. Okay, so let me go through this again.
And we'll get to the questions towards the end, just so you know. Thank you.
So I apologize. I don't know what happened there. Let me. I was talking to myself that whole time, I guess. Okay, so let's do this. So thanks again for everyone for joining today's session, Automating Production Level Machine Learning on AWS. My name is Mark McQuaid. I'm a practice manager at Onica within our data science and engineering practice. And I'll quickly just go over the agenda. So, today there's not a ton of time, especially now after I've just talked to myself for 20 minutes. But now, I won't dig too deep technically, but as I said, there'll be a Q&A. So feel free to send in any questions throughout the presentation. I see people have already been doing that. Yeah, and you can reach out to me after the fact as well on LinkedIn. So we'll talk about why customers need ML operations. Introduction to the Model Factory framework, what that is. We'll talk about some features and how it works. We'll go through some customer benefits and value prop, and then as I said, we'll go into a Q&A. So we've entered an age where no business plan is complete without an ML strategy, right? Companies are realizing the value of using machine learning to drive outcomes for their business. In addition to using their data in a reactive mode with business analytics tools, companies are harnessing the predictive power of their data with machine learning. As a result, ML models are becoming as an important tool in business operations as data processing and data analytics tools were and have been for a decade. As well, getting your ML models to production in a timely manner is key. However, developing domain-specific ML models is only a first step in your strategy. Operationalizing your models and taking those models to production to drive business insights is more complex than people think. What we see a lot today in organizations is that there's a ton of research that goes into development of the model itself, so in model development. However, the models never get to a production environment due to the disconnect between the operations or DataOps teams and the ML engineers. So another common problem is models tend to increase, right? They tend to multiply based on use cases, and they multiply in different environments. So think of a bank operations as one example, and the number of different areas that can benefit from predictive data analysis. From identifying fraudulent transactions to risk assessments of mortgage applications. Data scientists will create domain-specific models and run many experiments, first in a dev environment and then in a testing environment. So this results in multiple models running simultaneously across different environments using different data sets and different hyperparameters. So it becomes virtually impossible to keep a model's lineage without an operational solution in place, really. We hear from our clients that it might take them just a few weeks to develop an ML model that addresses their business needs, yet it will take them months to have this model deployed into production, if ever, really. So our clients were looking for a solution that would combine data prep, model training, deployment, model monitoring, all in one workflow or framework across multiple environments, all while maintaining strong governance and security controls. So why is DevOps not enough? So DevOps culture and application lifecycle management have become, kind of a standard in the IT industry over the last decade. It emerged to fill the gap between an organization's ability to develop application code and the way to efficiently deploy, update, test, scale, and monitor those workloads. Mature CI/CD pipeline needs are largely addressed nowadays in application development by the industry standardized tools and best practices. Now, unlike application development, where quality comes from the code itself, the quality of an ML model comes largely from the data features used to train it. Now, the importance of the data features cannot be understated. Their quality drives the ML model's performance. Now, it is worth mentioning that machine learning models are really in their operational infancy. Additionally, data might change daily, and the data that was used for predictions today might be significantly different from the data used to train that model a month ago. So in this case, the production model needs to be retrained, right? And it goes back into a development phase. As a result, ML models' life cycles are significantly different from the application lifecycle. In fact, we actually had a customer in fraud who wanted to push production models every 24 hours to account for new threats. The customer would retrain and redeploy their model every day to be able to account for this drift in data. And that is impossible without a mature solution for model operation in place. So here, this is just your typical machine learning lifecycle steps. There's many steps to an entire machine learning lifecycle. As you can see, each step has its own set of challenges. Now you have data ingestion, analysis, transformation, then validation, data splitting, then training. Right? You're going to build the model, validate the model, training it at scale, roll it out, serve it, and then monitoring and logging. So it's complex, and with all these steps and their associated challenges in mind, that's kind of the reason why we developed the model factory framework. So with that, I'd like to introduce the Amazon ML stack. AWS sinks a lot of energy, time, resources into their AI platform nowadays, and it's really turned into their flagship offering. This is kind of AWS's bread and butter right now is AI. So as you can see, it's a 3-layer stack. On the top layer, you have your AI services layer. So that is your pre-built artificial intelligence services. They come out of the box ready to go. You don't need to be a data scientist or machine learning engineer to use these services. AWS's kind of slogan is they want to put ML in the hands of every developer. So that's kind of what they're built for. And they cover different verticals. So you have vision, which anyone who knows any AWS services, you'll recognize some of these. So from a vision perspective, there's Amazon Recognition, speech, there's Poly and Transcribe, which is speech to text to speech, speech to text, language services, Amazon Translate, which is a translate service, Comprehend, which is an NLU NLP service, chatbots, which is your conversational bot service, which is Amazon Lex. The name isn't on there, but and then you have some fairly new services like Amazon Forecast for time series forecasting and Recommendation Engine, which is Amazon Personalize. So that's your top level layer. Then you have your ML services layer. So that's your Amazon SageMaker layer. So, if anyone doesn't know what SageMaker is, that is your end-to-end machine learning platform within AWS. One-stop shop for build, train, and deploy your machine learning models. And as you can see, there's the steps, not limited to, as it's also worth mentioning, the AI services, that's not a full complete list. That's just ones we wanted to highlight. There is additional ones on that. And So back to the ML services layer, in the build category there, you could perform data labeling within SageMaker using a service called Ground Truth. You could use SageMaker built-in algorithms. You could grab machine learning models from the marketplace, the machine learning marketplace, which is a place for people that have built their own models are now selling them. So you don't have to do any of the legwork or heavy lifting. You can just grab a model from the marketplace for a fee, of course. And then notebook hosting. So that's think Jupyter notebooks in the cloud. So think the SageMaker notebooks is just Jupyter notebooks in the cloud. And then the train section, you have one-click model training and tuning, optimization, which is Neo. SageMaker Neo enables developers to train machine learning models once and run them anywhere at the cloud, in the cloud and at the edge. SageMaker Neo optimizes models to run twice as fast. Hyperparameter optimization and reinforcement learning is also supported. And then in the deploy, you have one-click deployment hosting, auto scaling. You can put everything in a VPC, and then Elastic Inference integration. Elastic Inference is an accelerated compute service that allows you to attach just the right amount of GPU-powered inference acceleration to any SageMaker instance or EC2 instance for that matter. Now, the third layer is your ML frameworks and infrastructure layer. So that is, that's for full control. If you want full control of the underlying infrastructure, then that's where your data scientists and ML engineers want to work, right? They don't want to work in the confined space of SageMaker. They're going to go to the ML frameworks and infrastructure layer. So this is, think your own EC2 instance. Maybe it's a GPU-backed EC2 instance running a deep learning AMI, and you're able to, run all the frameworks that you'd like yourself on an EC2 instance. Could be TensorFlow, MXNet, PyTorch, what have you. So it is worth noting that the Model Factory framework, what I'm talking about today, can also function outside of this stack. For example, using services like EKS, right? Elastic Kubernetes Services, which is managed K8s within AWS. So yeah, it doesn't have to be set and confined to any one of these layers. So one aspect that's not quite mature in this stack is the lifecycle management and integration components that allow orchestration of machine learning. Additionally, we truly believe that each customer is different and should have the flexibility to choose their own platform based on their existing processes and their own tooling and their own skill sets. So while AWS provides a great set of services for machine learning, as you can see, some clients may still require an end-to-end machine learning blueprint and ability to run across different platforms with ease. So introducing the Model Factory framework, so cloud-based machine learning lifecycle management solution. So what is the Model Factory framework? So the definition, the Model Factory is a machine learning operations framework built on AWS using open source tools that enable rapid development, training, scoring, and deployment of models. So Model Factory itself is more of an architectural pattern than a product. The Model Factory framework was built to address the problems our customers were facing with taking ML models from development to production. Right? One of my colleagues, one of my peers within the data science and engineering practice at Onica, who's also a practice manager, his name is Gus Mohammed. He was kind of the driving force behind the development of the Model Factory framework. He was working on a client engagement. And he noticed, they had a full team of data scientists, and he noticed they were just having problems taking those machine learning models to production. So I told Mohammed, his name is Gus Mohammed, but he goes by Mohammed. I told Mohammed I'd give him a shout out. So I wanted kind of a quote from him behind his mindset when he was designing this. So Mohammed said, the primary motivators for Model Factory was to bridge the gap between data science and operations, and also to reduce the time to get ML models deployed into production, right? It's a fairly simple premise. And then as well, Jerry is also on this call. He's moderating the chat. When I would disappeared for a while there without knowing it, I'm sure he was chatting. But Jerry was instrumental in building the content for this talk, as well as Jerry's kind of the feet on the street, working on our Model Factory engagements with clients directly. So I wanted to give Jerry a quote as well. What he thought Model Factory was. So Model Factory, he says, is the architectural framework providing simple but effective set of processes and tooling to allow data scientists and operations to collaborate, enable model development, automate packaging, and deployment to multiple environments. It does this in a consistent and platform agnostic manner and more importantly, makes it much easier to integrate existing model code. So, you know, those are kind of the quotes from the two most knowledgeable people within our company on the Model Factory framework. And as I said, I did promise them both shout outs, so perfect. So the solution is built using open source tools, and it is a flexible framework that allows integration with AWS services, as well as industry standard automation tools for data processing. So this could be Jenkins, it could be Airflow, it could be AWS Code Pipeline. AWS Code Pipeline is part of the AWS native CI/CD tools. The main concerns of a model's governance across multiple environments have been addressed through experiment tracking, which is visible through a tracking UI. And as you can see in kind of the squares and rectangles on this slide, this is kind of everything that Model Factory framework involves, kind of wrapped into a slide. Model Factory also supports deployment of the model into different hosting platforms. So it doesn't have to be SageMaker, it can be K8s. It also supports a wide variety of frameworks such as TensorFlow, scikit-learn, SparkML, Spacey, PyTorch. The solution is highly extendable and can be customized based on the business needs and domain requirements, right? So fully customizable. And it's an open and pluggable solution allowing use of different CI/CD and ML pipeline tools. So some of the benefits. Now I'm just going to go through, Tanya had a slide up earlier about the challenges. I'm just going to go through, kind of corresponding benefits to those top challenges and what Model Factory provides. So standardized model development environment for your data science teams. So no more multi-environment model deployments and no need for data scientists to worry about which environment to put their model. Automated model deployment across dev, QA, production, right? Everything starts out in a dev environment, and through automation, everything gets promoted, of course, when ready, to the next environment and stage. So reproducibility of models and predictions. So this allows for data scientists to easily duplicate models and model outcomes in many environments. Tools for diagnostics, performance monitoring, and addressing model drift. So Model Factory allows for complete tracking of your model, allowing easy access to diagnostics, performance of that model, and catching any model drift, right? That's extremely key, catching that model drift. Model lineage for governance, right? Model Factory also captures all models lineage for easy details, description, or explanation of that model. Platform for collaboration. So data scientists no longer have to work in individual silos, right? It's all collaborative. Accelerated ROI, faster time to business insights. So Model Factory allows for you to take those models into production in a timely fashion, allowing you to get that return on investment you envisioned when you started using machine learning in your business in the first place. So here I'll just talk a little bit about, without Model Factory and with Model Factory and what that looks like with a model development lifecycle. So without Model Factory, your whole lifecycle could take months. It could be 25 plus steps. It could start in a local dev, then have to go to maybe a cloud dev, QA, prod, right? With Model Factory, it's reduced to just weeks and 10 or so steps. Manual handoffs between various teams. So automated, with Model Factory, it's automated, right? Everything's automated. Automated deployment between environments. It also has controlled access to data teams for specific steps. Without Model Factory, cycles of troubleshooting between data scientists, local dev, right? And data engineers development environment, right? There's that disconnect. Now, with Model Factory, one source of truth for experiment tracking, project packaging, and easy source control and reproducibility. So I mentioned that Model Factory solves the challenges that we talked about, both from the perspective of a data scientist as well as an operator. Now I'd like to just go more in a simplistic approach to align some of those solutions to the overall model lifecycle features. Time is short, right? Especially because I've taken twice as much time as I should have with you. And so I'm just going to kind of skim over this. Feel free, as I said, ask questions in the Q&A. So first, model development. So, Model Factory solves a lot of challenges within the model development stage. So development environments, that could be notebooks, IDEs, automated environments, algorithm selection, hyperparameter tuning, dependency management, consistent packaging, model tracking, A and B testing. All of it is wrapped into that model development stage from within Model Factory. Model deployment, right? So it supports multiple platform backends for the same model code, right? So that could be SageMaker, it could be EMR, it could be ECS, it could be EKS. ECS is Elastic Container Service from within AWS, picture managed Docker. It supports promotion view, right? From dev stage to prod, tracks revision history on all upstream artifacts, supports real-time, batch, and streaming inference pipeline. Monitoring captures model requests and responses for comparison, right? And then detailed analysis. Provides data quality metrics using Apache DQ. Provides infrastructure monitoring. Tools to address both data drift and model drift, which is massive, right? In the world of machine learning. Governance and security. So you have clear separation of data and model artifacts, granular access controls, rule-driven access, right? It could be any IDP or Amazon Cognito in the AWS world. IAM authentication for access to backend data stores. IAM is identity and access management, and from within AWS, and RDS is relational database service. It's managed DBs, right? Cryptographic key management using a service called KMS from within AWS. Data lineage and traceability using tools like DVC or Delta Lake. Extensive use of tagging for auditing and accounting, right? Any auditing or accounting, using tagging throughout your AWS account is very key. Okay, so as I said, I didn't go into too much detail on that. I just wanted to touch upon it. Now here, I just want to touch upon, a visual architecture pattern of what the model factory framework looks like, or shall I say a sample architecture of what it looks like. I find I like to see visuals. I like to see diagrams, lucid charts of exactly what what that looks like as an architecture. So I did want to show this, and I will summarize it. I won't dig too deep into it. As you can see, you have a development, staging, and production stage. It's kind of a busy slide in the sense of all the services and tools used. But if you're familiar with AWS in any way, a lot of this will jump out at you. And as I said, Model Factory can get a little complex when you're putting it all together like this. There's a lot of steps, but its premise behind it is extremely simple. So, in summary, in the development phase, data scientists perform exploratory data analysis of the data and model. They then evaluate the enriched features, choose an appropriate algorithm for the problem. They may develop locally in an IDE or remotely on a Jupyter Notebook solution of their choice. Okay. And then at the staging QA stage, right, data scientists feel sufficiently confident about the model, and they wish to test the model using a larger production data set, which has undergone sufficient refinement to comply with the organization's security and compliance. In order to facilitate the testing, all the data scientists need to do is wrap up the sample blueprint project and model code and push it into a Git repo in the staging branch. At the production stage, data scientists have evaluated and tuned the final model algorithm against production data set under various hyperparameters. The data scientists and operations have an agreement then on the desired model using global unique identifier for the experiment run. So we use this identifier to promote the experiment by updating a production branch of the Git repo. Upon doing this, the final model is pushed to production endpoint and can be used for the downstream applications. So again, very high level, kind of just wanted to summarize what's happening here, but please feel free to ask any questions. So here I just wanted to quickly talk about a customer success story, a use case. This was a project we did for a water and utilities company. The problem they had, the customer had several machine learning models already designed and implemented in various experiments, and they were seeking a consistent mechanism to quickly track and best experiment runs, as well as managed hosting platform with automated deployment and promotion pipelines. So we proposed a model factory solution, and as part of the phase one of the engagement, we tuned and integrated the models with MLflow, which allowed us to track, package, and deploy the models, and we use SageMaker in this case, into the SageMaker platform. MLflow is actually ML framework agnostic, and it provides support for TensorFlow, PyTorch, Keras, scikit-learn, SparkML, etc. So as part of a phase two of this engagement, we utilized AWS services, right, such as Code Pipeline and Code Build, which are part of the AWS native CI/CD tools, as I mentioned, and we were able to design and orchestrate the promotion pipeline for training and deploying inference endpoints and batch jobs. So essentially, we stood to achieve through this ML pipeline. What we wanted to do was facilitate and ensure a quick turnaround time for training and deploying models to production. Okay, common trend, right? Some of the AWS services we used as part of this solution were SageMaker, EMR, Code Pipeline, Code Build, Amazon Athena, which is a SQL querying tool from within AWS, S3, and ECR. ECR is Elastic Container Registry, picture Docker Hub within AWS. Some third-party applications or solutions that we used were Python, of course, MLflow, TensorFlow, Horvid for distributed training, Petastorm for accelerated ingest into TensorFlow using Parquet. And some of the outcomes were that the customer was able to consistently package and deploy all their models. They were able to track and compare their parameters and accuracy metrics across different experiments. They were able to uniquely identify each experiment run, models, and any associated artifacts using that ID, irrespective of the ML framework utilized. And they were able to get a quick turnaround time to pre-processing, training, and testing the models simply by checking the model code changes into their source control. So that is it for me for the second time. Now, I'll go to a Q&A, and I appreciate everyone for joining. I appreciate everyone for sticking through that. I'll turn it over to the Q&A portion. I see there's probably been some questions that have come in. Jerry, if you want to.
Yeah, sure. Sorry about that. Yeah. Thanks, Mark, and thanks, Tanya, for that. Like a great presentation. I know there was a bit of a glitch, but we got over that. That's great. Thank you. So I have a few questions down in the that I've been collecting in the chat box. So first off, just a huge shout out to Kaushik for replying to most of the questions there. Really appreciate it. And he mentioned some concern over tracing data. And like Mark pointed out earlier, one of the tools that you could possibly use and help you down the road is using tools like DVC, which helps us essentially do data lineage as opposed to the model lineage. The model lineage is essentially taken care of by the framework that we choose, whether it's MLflow or Kubeflow. It is able to trace the experiments, the hyperparameters, even the target output for the label data set. But there is not a whole lot of tooling or integration, native integration, I would say, around data lineage. And DVC, Delta Lake, Hoodie, a few such frameworks allow us to actually trace back what we actually use for the training data set. And some of these tools are pretty complicated. DVC, I believe, is slightly simpler, but Hoodie and Delta Lake are much more mature offerings or mature libraries, which you can use to actually do that data lineage. Now, Kentes Sado had a question. So he asked, we train ML models on on-premise GPU server to save cost and deploy models in code for batch inference on AWS batch. How would you approach this hybrid solution, hybrid configuration between on-prem and cloud? I think to delve deeper into your architecture, we might need a bigger session, but essentially we have, I don't personally see an issue dealing with such hybrid configurations, provided that we can actually reach out to AWS as a target platform, whether it's AWS Batch or another offering. Now, if you want to train your models on-prem, however, we just need to make sure that the libraries of the framework that we are choosing have plugins so as to target the on-premise service. But having said that, I would suggest you take a look at Spot instances, Spot GPU instances, on whether it's on SageMaker or otherwise, to make sure you're estimating your cost right now. I'm sure you have been doing that, but just try to compare on-premise training on GPU devices as well as trying to deploy to AWS and see the Spot instance cost, because I'm sure you will have at least a comparable or even lesser cost on AWS with those Spot instances, given a certain time, because the Spot requests or Spot prices vary from time to time. But to answer your question, we can easily set up plugins so that the target platform is on-premise or AWS? And there's a follow-up question from Rylev asking a similar question, but I'll get to that in a bit. Sorry about that. Just making sure I answer them in the same order. So Corey had another great question. So he asked, AWS speaks about SageMaker Studio edition, which was recently announced and probably in GA, I think, providing end-to-end pane of glass for model development and deployment. As I look at this, can I assume that SageMaker does the modeling activities and services and provide ML ops competence needed? Yes, so the idea is that like Mark mentioned, the SageMaker offering or the ML offering as such provides different layers, as Mark showed, that AWS offers, and all of these as itself performs great for that function that it does. However, there's a little bit disconnect or immaturity, or there's a need for maturity essentially when it comes to lifecycle management and orchestration of the model development. So whether you're talking about data engineering or feature engineering, I would say, all the way down to the training, the inference. So there is a bit of a disconnect in terms of the actual orchestration, and that's where we come in and sort of fill the gap. And to answer your question specifically about the Studio does a whole lot of things. And in fact, along with Studio, they released things like Model Monitor that I mentioned, Model Debugger, and a few other tools or offerings. However, it doesn't cater to the orchestration that we are trying to talk about, whether it's the exploratory analysis that the data scientists initially do, all the way to pre-processing of feature engineering and training, and finally the deployment. And one other thing to note is that SageMaker Studio caters to, as you can imagine, SageMaker related services, whether it's training or for inference. It sort of forces you to use that ecosystem of tooling, if you will. However, what we're trying to do is making sure that we can target other AWS services as well, whether it's EKS or otherwise. And just to reinforce that, the SageMaker team recently announced something called a SageMaker operator, which allows you to deploy custom resource definitions in Kubernetes, if you're familiar with those, which means that you can define essentially your workload in a very domain-specific way, right? That's what CRDs are used for. So they allow you to define what is known as SageMaker operators. So what ends up happening is when you deploy those operators when you deploy those custom definitions to Kubernetes, it ends up executing the workload on SageMaker as opposed to Kubernetes. What we are trying to do is making sure that the customers have the ability to actually execute in Kubernetes or any other platform of their choice, EMR or otherwise. We are trying to avoid having to use one single platform depending on the customer's use case. And this goes back to the point that both Tanya and Mark mentioned, trying to integrate with your existing ecosystem of tooling or skill sets or otherwise, and not introducing something new. And we have had a lot of pushback from both data scientists and AI engineers alike when we try to push a service to them, right, that they're not familiar with, because that changes their whole workflow. So we try to avoid that. And I'm sorry for going on that huge rant. Okay, so Rylov, coming back to your question. So is Model Factory platform agnostic? Can we use this for outside AWS, for Azure or any other similar cloud platforms? Yes, so like I said, it wouldn't be truly a platform agnostic if we didn't support other platforms. So there is initiative within our company, Rackspace, that goes on to deploy the same Model Factory architecture on different platforms. So that way, what we envision is that there is a hybrid platform, whether some customers actually use multiple cloud platforms, right? As you pointed out. So we want to make sure that that same experience is replicated across these different cloud platforms and not have, drastically different experiences. So that way we have a single coherent experience throughout the organization. Now, Nadia had one question. What is the best way to productionize a Spark pipeline model in SageMaker? I know there are multiple options all in SageMaker using MLflow. I'm looking at recommendations. So one thing that we do for Spark pipelines, Nadia, is like Mark mentioned earlier, we can target EMR, for example. That is one way to target essentially the execution of the Spark pipeline, whether it's for your training needs or inference needs. So you can do that. So that way you stick to the execution of a single platform. And we have done that for the utility company that Mark went over earlier. Essentially what we did is they essentially had an initial data set for a specific use case concerning a specific one state. And then all of a sudden they wanted to scale it and have around 15 states worth of data. So we couldn't do it using pandas. So what we ended up using is creating a plugin for EMR and made sure that that training process or the pre-processing prior to the training happens on an EMR platform, right? So that is one way of using it. Now, there's also a new mechanism within SageMaker called SageMaker pre-processing. However, it is not as mature yet, but it is a great utility if you want to do Spark all in SageMaker. But there's still development going on, I believe, because essentially when you look at the SageMaker console, if you're familiar with it, you will see all of the services in the console as well as the API. However, preprocessor is one thing that is not reached all spaces. So for example, if you run a Spark pre-processing job, you may not see it on the UI. You may not be able to track it as efficiently as you would a training job. So that is one thing to note. But definitely look out for setting up plugins for EMR. You could do that too. You could do that with MLflow. You could do the same thing with Kubeflow as well. And for Kubeflow specifically, there are EMR components. So essentially what you do is you write your code and create a DSL component, as they call it, if I'm not mistaken, Kubeflow DSL component, which could package it up into a Docker container and execute it on an EMR cluster. So that is one possibility. Yes, so I think we're good with questions. If you do have any other questions, oh, wait. Okay, I see a question from Javed Siddiq. Can you share a link where I can read more about the platform? So I do have a pamphlet. There's more of a, I'm sorry, but it's more of a marketing slide, but you can reach out to us directly, like I said, either through the Hova app or via LinkedIn. No problem, Corey. So Javed, you can reach out to us via LinkedIn or the Hova app, so that you can get more visibility into how it works under the hood. Yeah. So if there are no other questions, so the reference it was okay. So Corey had another question. This is also a reference to Model Factory. He posted a gist. Yeah, I'm familiar with this gist. Actually, this was posted by somebody else. I frankly don't know. This is a totally different initiative from another company, I guess, who actually took on Mohammed's copyright name and codes, Model Factory. But yeah, that's a different initiative. I'm not familiar with it. When we were trying to sort of trademark, if you will, our platform, we did check that out. It seems to be an initiative by another company, and we are not affiliated with that particular offering. Yeah, I think Mark, if you don't have it, Mark and Tanya, if you don't have anything else to add, you can always reach out to us with the Hova app. I believe it does a whole lot. You can do networking, and I think it also lists down the future meetups and things like that. So if you want to check that out, please do. And if you want to reach us, you can either do that using this app or at LinkedIn, on LinkedIn, sorry.
You can reach me on LinkedIn, anyone. My name is Mark McQuaid, obviously. So, and thanks again, everyone. I really apologize for that. I legit ran through the entire presentation not knowing that I was no longer connected. And, I had everything on D&D because, I'm doing a presentation, so I couldn't get notified, and hopefully you stuck with me. Thanks, Jerry, for covering too. Covering the, covering while I was speaking to myself.
Of course, no problem.
All right. And we'll share out any content or anything after the fact. And I appreciate everyone for joining, and everyone have a great rest of your day.